Okay, so we have a pharmaceutical company testing the effectiveness of a new drug for lowering cholesterol. As part of this trial, they wish to determine whether there's a difference between the effectiveness for women and men. So they're looking for a difference. We know that. If we're doing step 1, the mean for women is equal to the mean for men. That's the null hypothesis. Alternative hypothesis, the mean for women is different from, so it is not equal to the mean for men. That's our null and alternative hypotheses. Second step, critical value. And you determine that critical value based on alpha equals 0.05, and this is not equal to. So if it was less than, it would be left-tailed. If it was right than, it would be right-tailed. Greater than, it would be right-tailed. But since it's not equal to, it can be greater than or less than. So 2 tails. 2 tails, alpha's 0.05. Let's go to our formula sheet. Oh, I'm right there already. 2 tails, alpha's 0.05. So I'm in this column. 1.96. And I kind of skipped this step. Because I automatically jump to the z distribution, right? And we're using the z distribution because we know sigma, the population standard deviation. But I know you're thinking, wait a minute, I don't see population standard deviation here. I see population variance. Well, you have to remember that sigma squared is the population variance. So if I take the square root of this, the square root of the variance, I get the population standard deviation. So if I take the square root of that, the square root of this, the square root of that, I'll get the population standard deviation. Okay? So I do know the population standard deviation. Just want to be clear on that. So 1.96, negative 1.96. Those are our critical values. If it asks for critical values, we would give both. Negative 1.96, positive 1.96. Now the test value. Let's look this up because we haven't done this yet on this review sheet. So how do we find the test value? Chapter 9, because this is two sample test. Z-test, here's the formula. It's a bit much. You can do this in the calculator, or we can do it by hand. Either or, I'll write out the formula. Okay? So here's the formula. Z equals x bar 1 minus x bar 2 minus mean 1 minus mean 2 over the square root of sigma 1 squared divided by n1 plus sigma 2 squared divided by n2. Let's gather all of our information. This is sample size, so this is n1, n2. Mean, population mean 1, population mean 2. This is sigma squared 1, sigma squared 2. That's actually what we need for the formula. Sigma squared. Because the population variance is sigma squared. So I'll do this both ways. I'll show it in the calculator, but I'll show it here first. So 9.4 minus 8.7 minus. Now, remember our null hypothesis was the means were equal. So if they're equal, when I subtract them, excuse me, when I subtract them, I must get 0. All right? Don't worry, y'all. I'm okay. Right? When I subtract them, I must get 0. Okay? Sigma squared 1 is 3.6 divided by n1, which is 70. Plus sigma squared 2 is 5.1 divided by n2 is 40. Let's go to the calculator. Okay, so let's clear that. Okay, so in my numerators in parentheses, 9.4 minus 8.7, close parentheses. I don't need that minus 0 because it's just going to be itself. denominator in parentheses, second square root. So I've got 3.6 divided by 70 plus 5.1 divided by 40. Close parentheses, close parentheses. So 1.65 is that z-test value. 1.65 is that z-test value. That's the answer to the question, but let's do it in the calculator as well, all the way in the calculator as well, so we can double check ourselves. Stat, I'm going over the tests, but this time it's a 2-sample z-test because I know population standard deviation. 2-sample z-test. And I'm entering statistics. I got a lot of stuff to enter. So sigma 1 is the square root of that. So I'm just going to put it in, square root of 3.6. And see, it takes the square root of it automatically. Sigma 2 is the square root of 5.1. Square root 5.1. X bar 1 is 9.4. N1 is 70. Be careful with what they're asking you to input, right? X bar 2 is 8.7. N2 is 40. This is a not equal to. It's going to ask you about pooling. Or, oh, this one doesn't. Sorry, wrong part. Calculate. Z equals 1.65, exactly what we got before. You still get the p-value in case you want to use the p-value method. It all comes. So 1.65 is our answer. That's the appropriate test value. And just to go further, that test value is here in the non-rejection region, so we do not reject the null hypothesis. Do not reject the null hypothesis. Hold on. Here's the claim. Oops. Sorry. Okay, forget it. That's the answer.